Okay, so what I'm going to look at today is what exactly makes fractions in third, fourth, and fifth grade so difficult. So this app here looks at all of the fraction standards from third grade to fourth grade to fifth grade. There are no fraction standards in kindergarten, first, and second grade, although there are geometry standards that look at partitioning shapes, and they use language like halves and thirds and things in second grade. So it gives them a little bit of a heads up, but they never really actually teach what a fraction is in all of its depth and complexity. So in third grade, it starts with these three skills. That's it. Number lines, adding and subtracting, and comparing. And a lot of what third grade standards are focused on understanding and representing. These standards, in each of these third grade standards, really focus on just understanding. Okay? So however a child or a student decides to show their understanding or explain equivalence, right? And show their understanding of what these ideas are, in comparing, adding, subtracting, and creating number lines, is not detailed in the standards themselves. How a student learns and when a student learns isn't determined by the standard itself. So the first thing that makes this kind of tricky is when we as adults look at a number line like this, we immediately have a conceptual understanding of what this is. But to a third grader, to an 8-year-old, 7-year-old, 9-year-old, this might be the first time they've even ever considered how to communicate a number between 0 and 1. And so having their experience really only focused on counting whole numbers and then suddenly realizing that, wait, if we theoretically have something that is a pencil that is that long and we break it into 10 equal pieces, why would we do that? That's hard for a third grader. And then saying, all right, well, if this is half, right, of the pencil, and again, in second grade, they've introduced the words like half and thirds and things in shapes, but now we're applying numbers to what the idea of breaking and partitioning shapes is all about. And so if we break that length into 10 equal pieces, then half of 10 is 5. And we can show that. And this takes a long time for students to really grasp and get good at and be able to do this with, breaking a length up into different shape, different lengths, using rulers, using different things. And so definitely get used to the idea that one of these pieces is going to be one of these 10. And so just making that transition into introducing the language and the symbols for what is 1/10 of a whole is a lot. That is a lot. And so just completing worksheets might not be enough to really grasp the conceptual understanding of what this is. So then when the students are introduced to adding these, if you have this length of a pencil, and then you have another pencil that is this length, then you got 1/10 and you have 3/10. And they say, okay, well, if you line them up, how long is it? Well, you're adding, aren't you? And so just knowing that this piece is one of the 10 pieces, right? And this length is 3 of the 10 pieces, then we're going to end up with something that is 4 of the 10 pieces long. And that, again, I'm telling you, that's going to take some time, and students are going to find different ways to show you that this makes sense to them. So this way that I just did it might make sense to a couple of students, not all of them. Really allow students to explore and share and talk about different ways of communicating the concept, okay? Because adding these parts and then realizing that, well, wait a minute, what happens when we have something that is 3/10 and 8/10? And as adults, we know that that's going to end up being 11/10. how do you deal with 11/10? It's more than the whole. My mind is broken. That's going to start getting introduced in 4th grade. Okay? In 3rd grade, it really is just conceptual understanding of what a fraction is, adding and subtracting, and comparing which are bigger, which fraction is bigger, and looking at the word equivalence, whether or not it is less than, greater than, or equivalent. Okay? And that's it for 3rd grade. There's no multiplying, no dividing, none of that. Okay? So instead, when we get to 4th grade, we're going to see a really big jump, not just in using fractional models where students have to show fractions using those fraction models, right? Which is kind of a nice transition into 4th grade. But 4th grade, just like these ideas of fractions that are more than one, these improper fractions, right? Which are going to create, which is essentially 1 whole plus that extra 1/10, you're going to end up with a mixed fraction. Okay? So that is introduced in the beginning of 4th grade. And the idea that these two fractions, this improper and mixed fraction, are the same, we have to get used to that. This is a new language. That's what makes this so challenging. So have grace with your 4th grader because this is all new. And you don't want to damper their desire to explore and explain and experiment. And if it's wrong, don't worry. Don't worry, because if you focus on the logic, then they will be able to fix it in their own time. So here, when you're adding and subtracting, you see we're starting to deal with mixed numbers. We're starting to look at how we can use whole numbers and break them back up from mixed numbers into improper fractions, right? We're taking that initial question, what happens when we end up with more than 1 whole as a fraction, and turning it into mixed numbers and being able to turn it back into an improper fraction so that we can add all the pieces and understand conceptually why just adding the whole numbers and the fractions separately first and then fixing it later, why that procedure is faster. But being able to understand how to break those up is a tricky idea. But that concept is not just helping them do math, it's helping them develop their cognitive capacity in their mind to really manipulate quantities. And that's going to help them do so many life skills later. So don't just teach them the shortcuts. Really let them struggle and explore and communicate these ideas, because when they get it, they're gonna jump with joy when they do. And then 4th grade, comparing. This is where we introduce common denominators. This is where we start to take the 1/2, this whole idea of 1/2, and saying, well, 1/2 is more than 1/3, right? 1/3 isn't here. You can have 1/3. But that whole idea of comparing, this real simple idea, 1/2 is more than 1/3, well, that's a 3rd grade thing, right? So now what we're doing is we're taking this and we're saying, all right, well, let's take 1/2 and turn it into 3/6. What? That's what I mean. This is where we really start to get into what it means to have 1/2, right? And then that same circle, if it were broken into 6 equal pieces, and again, 2nd grade is all about partitioning shapes, and 3rd grade introduces the fraction numbers, the symbols, for those partitions. So there's been a clear development, a clear progression of skills from 2nd to 3rd to 4th, where these 3 parts of the whole 6 is the same as 1/2. So this is a 4th grade standard that's really important, because once you figure out how to do that and then have to do the same thing with 1/3 and 2/6, 1/3 piece and 6ths, of course, is going to be that same everything here. Then you got the 1/3 and you have the 2/6. And when you do it messy like this, it's really hard to see that they're equal. And so there's typically worksheets with nice, neat lines. Once you understand the concept behind it with nice, neat lines, then the student is able to communicate with, maybe a little more loosey-goosey with the lines. But essentially, if you know that these are the same, then you can add 1/2 and 1/3, right, by breaking it up into smaller equal pieces. So now you got 3/6 and 2/6, that equals 5/6, right, if you're going to add them. But if you're comparing them, you can now see that 3/6 is more than 2/6, right? And of course, you can even break it up into 12 pieces, but I'm not going to do that right now. And this skill is how you find the common denominator so that you can do a lot of cool other things. But also in 4th grade, you start to learn how to multiply. So that idea is, if you learned multiplication in 3rd grade as repeated addition, then recognizing repeated addition in fractions shouldn't be that more difficult. It's essentially that 3rd grade standard where you're adding fractions, simple fractions. So if you understand that idea, then you can build on it. And then from 4th grade multiplication, there is no division. So these skills prepare your student for 5th grade, where you start to add and subtract with more complex mixed numbers. This is kind of just an extension of 4th grade. You're not comparing because you kind of got that. 5th grade, you multiply mixed numbers and you find little tricks for doing that, and they expect you to interpret multiplication as scaling. This idea of scaling is new, so that's another concept that you can't introduce in 3rd. You can't introduce in 4th because there's a progression of understanding of skills and concepts that lead to this. So you introduce division in 5th grade. Never before, because in 6th grade, dividing fractions becomes a major standard. So there's a clear development of skills from 3rd to 4th to 5th when it comes to fractions, starting with 2nd grade partitioning of shapes. So I hope that helps. Take your time. These skills do develop on purpose in order, and whether your students in 3rd, 4th, or 5th grade, let them learn as they're ready through each part of each progression, okay? The grade levels are age-based, and not every student learns every skill at the same time. So have grace, be patient, and good luck. Have fun with your math.